Suppose you are asked to measure a certain volume in the lab, and the required volume is 10 milliliters, and you got exactly 10 milliliters. We call it as accurate measurement. If 2-3 team members from your class measured the same volume and they got 9.8, 9.7, 9.75 milliliter, we cannot call it as accurate. We call it as just precise, because these values are very close to each other. 9.8 is very close to 9.7, which is very close to 9.75. So we call it as precise, and we need 2-3 numbers to call it as precise. And so what's the definition for accuracy? Accuracy is defined as how closely individual measurements compare with the true or the accepted value. So what is precision? Precision is how closely individual measurements compare with each other. So for example, here in the dot and arrow picture here, all the 3 arrows are at the center of the dot, which is accurate, and all 3 are together, so it's good precision as well. In the second picture, all 3 arrows are together, it is good precision, whereas it's not at the center, so it is poor accuracy. In the third picture, all 3 arrows are far away and it is not together, so we call it as poor precision, and it is not at the center, so we call it as poor accuracy. So how will you report the values you have measured? In a correctly reported measured value, the final digits, here 8, 7.75, is significant but not certain. You can see that is uncertain. It is 0.8, this is 0.7, this is 0.75. So the first number is certain. Look at that, 999. But the second and the third digits, even though they are significant, it is not certain. So all the digits known with a certain certainty plus one final digit, which is somewhat uncertain. That is the way you have reported the values. Now, what are significant figures? We use significant figures to indicate the precision of the measured number, or to express the precision of a calculation with measured numbers. So you may be asked to find out the reported value to 2 significant figures or 3 significant figures, or there are rules how to determine the significant figures. That's what we are going to learn now. So how to determine the significant figures? When are the digits significant? Let us see. We use a simple way of determining significant figures, which is called Atlantic-Pacific rule. Even though you can find in the reference material there are 7 or 8 rules, this is going to be very easy, simple method. So what we are doing here is to find the significant figures with a digit with a decimal point. We move from Pacific to Atlantic side. Count the digits from left side, starting with the first non-zero digit. Say for example 40603.23. How many significant digits are here? Since there is a decimal present, we have to count from left to right with the first non-zero digits, which is 4 here. So how many are there? 1, 2, 3, 4, 5, 6 and 7. So there are 7 significant digits, or we will just call it as sig figs. So in another example, let us see this one. Again the decimal is present, so we have to count from left to right, starting from the first non-zero digit. So how many are here? 1, 2, 3, 4. So there are 4 significant digits, or 4 sig figs. So when there is a decimal present, left to right. Pacific to Atlantic, starting from the first non-zero digit. What if there is no decimal present? If the decimal is absent, we have to do the opposite, from right to left. Decimal point is absent, count the digits from right side starting with the first non-zero digit. Let's see an example. There is no decimal point here, so right to left starting from the first non-zero digit. This is the first non-zero digit, 6. So 1, 2, 3. So how many significant digits are here? Yes, 3 sig figs. Let's see another example. There is no decimal present, so from right to left with the first non-zero digit, which is 1 here. So how many sig figs are here? Yes, we are right, 1 sig fig. Another example, 0.400030. So decimal is present. If it is present, left to right with the first non-zero digit, 1, 2, 3, 4, 5, 6. So how many sig figs are here? 6. Another example, without decimal. So without decimal means we have to do Atlantic to Pacific or right to left. So starting with the non-zero digit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many sig figs are here? 10 sig fig. We can do more practice using the worksheet either in the class or tutorial time, and also we will practice while we are doing odd calculations hereafter. So main calculations involve addition and subtraction, multiplication and division. So in addition and subtraction, how we will decide how many sig figs should be there in the resulting answer? Let's see that. The answer to an addition or subtraction calculation should be rounded to the same number of decimal places, not the digits, as the measurement with the least number of decimal places. Let's see the example here. 12.52, there are 2 decimal places, plus 500.0, 1 decimal place, plus 8.24, there are 2 decimal places here. So the least number of decimal places is 1 for this number. So our answer should have 1 decimal place. So when you add and round it to 1 decimal place will be your correct significant digit in an addition question like this. Same goes with the subtraction. Take the least number of decimal places in your answer. Now, in calculations involving multiplication and division, round the answer to the same number of significant figures as the measurement with the least number of significant figures. So how to find the significant figures? I used to remember by using this mnemonics planer. So if there is a decimal present, I will start counting from left to right with the first non-zero digit. And if it is A stands for absent, and if the decimal is absent, I will start counting from right to left with the first non-zero digit. There is N and A is not required, but this makes me a word with the planer and makes me memorize how to use this sig fig counting. Is it from right to left or left to right? In order, it makes it easy for me to remember instead of remembering all 7 rules. So let's see an example with multiplication and division. So the question is 12 centimeters times 0.002 centimeters. It's easy to multiply 12 times 2. It is 24 and we need 3 decimal places, so 0.024 centimeters square. But how many decimal places or how many significant figures we have to have in the answer? So let's see that. So 12 means there is no decimal present. So if the decimal is absent, right to left. So 1, 2, only 2 significant figures here. And in this case, a decimal is present. So I have to count from left to right with the first non-zero digit. So left to right only one significant digit here. So in my answer, I should have one significant digit. So instead of writing 0.024, I have to write only one significant digit. This is how many significant digits are there? Present. So left to right with the first non-zero. So there are two sig fig digits. So I need only one. So I have to just write 0.02. So that's going to be my answer. Another example is 50.00 divided by 12.5. So this is division. Again, I have to go with the least number of significant digits. So here, how many significant digits? There is a decimal present, so I have to move from left to right with the first non-zero digit, so 5. So 1, 2, 3, 4 significant digits here. And how many are in 12.5? There is present, so from left to right with the first non-zero digit, so 1, 2, 3 significant digits here. So the least is 12.5. So in my answer, I should have 3 significant digits. So we can do a mental math here. What I will do first, I will think about 12.5 is half of 25. So 50 divided by 25 is 2. So 50 divided by half of 25, which is 12.5, will be, it's an easy mental math. It's 4, but I cannot just write 4 in order to make it correct with the significant digits. I should have 3 significant digits. So what I have to do, I have to add 2 more zeros here, 4.00. So when the decimal is present, I have to count from left to right with the first non-zero digit. So 1, 2, 3. So the answer will be 4 with the correct significant digits. So now check for understanding. Carry out the following mathematical operations and give each result with the correct number of significant figures. So you can do estimation. You don't have to use your calculator. So let's see, 21 minus 13.8. So here this is subtraction. So we have to use our rule, which is the least number of decimal places. No decimal places, so our answer shouldn't have any decimal places. There is a 1 decimal place here, so but we have to go with the least precise. So 21 minus, I will just round it, 13.8 can be rounded to 14. So 21 minus 14 will be 7. So your answer should be 7. So let's see another example. You try yourself and see whether you are getting the right answer. Use this formula, read the question, substitute, and do the mental math, and try to find the answer with the correct number of significant figures. Good luck.